Variability is usually a good thing when it comes to conducting experiments. But in some cases, the difference between two variables can cause a skew in the descriptive statistics. How do we solve this problem? Randomized block experiments are experiments that involve separating subjects into two or more categories. Usually the subjects are described using variables such as I and J. All experiments consist of a control and experimental group. Though mathematically defining randomized block experiments is a little complicated, Nedler, who wrote the analysis of randomized block experiments with orthogonal block structures, narrows it down pretty well. According to Nedler, randomized block experiments consist of reordering the values of each suffix at random and regarding the resultant vector of yields as a multivariate sample from the multivariate distribution defined by all possible permutations of the values of the suffixes. Now stay with me. This statement sounds complex given the advancement of the topic, but it's generally saying that the values are reordered to fit into homogeneous groups with each other. The whole concept of randomized block experiments is to highlight the statistics of the variable being observed. If there's a certain variable that is being analyzed with the experimental groups, the range and the differences of the test subjects can hinder the descriptive statistics of the experiment significantly. One statistic that is majorly affected by the variation is, you guessed it, the variance. According to Cornish, who wrote the article, The Estimation of Missing Values in Incomplete Randomized Block Experiments, if only a few variables are missing and the exact test of the significance is made in the analysis of the variance, the formula will not result in serious error. So, the more skew in the variance, the more applicable block experiments become. For example, a biomedical engineer wants to create an instrument that measures the strength of the human heart. The engineer wants the instrument to be effective enough, more effective than a stethoscope, and less intricate than an echocardiogram. They want the instrument to be less expensive to produce, yet efficient enough to give a thorough examination of the human heart. The instrument must consider the different body types for the examination to be accurate. Researchers must get the machine to consider height ranges, weight differences, and the different sexes. One block will be split into a range of 4 foot to 4.5 foot individuals. Within that same block, female and male must be separated due to the differences in blood pressures and etc.